we have Newton's second law says that F net equals mass times acceleration. So we've been looking at things accelerating. What I have here is a cart, and it rolls. The bottom of this, we have a reading of 472 grams. So that's the mass of the cart without any weights on here. Okay, so the cart now has a mass of 472 grams. I've got a mass here on the other end of the string of 140 grams. What we're going to do is start the cart down here so that it's pretty much lined up, hopefully, with the edge of this card. Okay, somewhere close to that anyway. And I'm going to hang this over the other side of the table. So we're going to have 140 grams of mass hanging by the force of gravity, right, or being pulled down by the force of gravity, putting tension in this string. We'll ignore the mass of the string. It's a very light string. Okay, and we're going to release this. I'm going to start the stopwatch here, so you'll have to watch the reading. When I release this, I'll say go, and you'll have to notice the reading on the stopwatch. We're going to time how long it takes for the cart to go from this marker to this marker. And that distance I've measured out carefully is 57.5 centimeters. So a little more than half a meter, 57.5 centimeters. Okay, so I'm going to try to get this arranged. And probably the easiest way for me to release this is to just let go of the string when we're timed to start, okay? And so as I lift my finger up, you'll be able to know when to start taking the reading off of the stopwatch. Of course, there is some friction here. There is some friction, and we're going to be getting into talking about friction. As a matter of fact, if we do this right, you should be able to solve out for the average coefficient of friction, kinetic friction for this situation, okay? So you'll have your ideal answer of what the acceleration of the system should be, okay? Is it lined up now? Okay, we're lined up. I'm going to start my stopwatch. So we have our distance, we have our timer. We should be able to predict, if there were no friction, what the acceleration of the system should be. And again, we're not perfectly level. There's no pulley over here. So we've definitely got a little bit of friction with the string rubbing, right? We've got some friction in the wheels, so forth, and air resistance. So we should be able to, we should get an answer for the acceleration. Of course, it's less than we might expect otherwise because of some friction. And then we'll be able to calculate the friction from this data. So let's go ahead and start the stopwatch. Ready? Go. Okay, so the reading that you'll want to take is what the reading was on the clock when the cart was lined up with the marker. That would be the elapsed time, the difference between the time when I started, when I lifted my finger up and released it, until the cart got to this point, using that as a marker.